Okay, so I'm out of class today for an IEP, so just to make sure we get through everything in class on time, I don't have to lose a day. I've got a video for you to look through of me going through examples we would have gone through in class. So section 6.3 was all about tests for parallelograms. And yeah, so basically, theorems about parallelograms, or sorry, not theorems about them, but tests to see if you have a parallelogram. So theorem 6.9 is to show if you can show that both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. Theorem 6, and if both pairs of opposite angles of a quadrilateral are congruent, then you can show it's a parallelogram. This one's a little different. 6.11, okay. If the diagonals of a quadrilateral bisect each other, then it's also a parallelogram. And theorem 6.12, if one pair of opposite sides of a quadrilateral is both parallel and congruent, it's got to be a parallelogram. And then, let's see here. So, how could you prove that a quadrilateral is a parallelogram? Show that both pairs of opposite sides are parallel. That's by definition. Show that both pairs of opposite sides are congruent. Show that both pairs of opposite angles are congruent. Show that the diagonals bisect each other. And show that a pair of opposite sides is both parallel and congruent. So those are the what do we got here? 5 ways. Yeah, 5 ways to prove something's a parallelogram. Okay, so for the homework, you had to try to sort out how in the world would you prove that this is a parallelogram, given the certain pieces of information. So, 7. Okay, or sorry, what additional information would be needed? Not what would you do? So 7. So for 7, there's a lot of things you could say. First, if you knew that AB and DC were parallel, you could, from theorem 6.12, you could also say that AB is congruent to DC. You could also say that because that's if sides parallel and congruent, it's going to be a parallelogram. You could also then say, or if you knew that the other pair of sides were parallel, AD and BC, that would also be a parallelogram. 8, AB and DC are congruent. Really, it's like 7. If you could show that AB and DC were parallel, that would be congruent and parallel. Or if you could show the other pair of opposite sides, which are AD and BC, are congruent, then you'd have yourself a parallelogram. Number 9, you've got angle DCA. Okay, now this is a little tricky. I'm going to use I don't have a pencil on hand, do I? Let me see here. Yeah, I do. Let's see if I can lead this guy. Not really. Okay, so you have to just use a pen and just kind of ignore the markings. So we've got angle DCA, which is this angle here, and angle BAC, which is this angle here. What we'd have in the drawing is we'd have a pair of alternate interior angles congruent, meaning that we're saying DC and AB are parallel. Okay, that's for number 9. Well, if that's true, if DC and AB are parallel, we really can just use the same arguments then from 7, that AB is congruent to DC, because you've got congruent and parallel, or AD is parallel to BC, because then you have both pairs of opposite sides parallel. Number 10, we're saying DE and EB are congruent. If we're going to do that, what that means is one set of diagonals has been bisected. So for 10, we want to show that AE and EC are congruent. And that's the only thing we really can do there, because we want to show that both pairs of diagonals bisect each other, because it's one of our ways to prove that parallelograms or quadrilaterals are parallelogram. And then number 11. Number 11, I'll do that in red. Okay. If you know that CDA, so here's C, here's D, here's A, so that's this angle, and DAB are supplementary. That's what this is saying here. That means you have a pair of consecutive interior angles that are supplementary, meaning those two guys are parallel. So really, if you're saying that AB and DC are parallel, you're back to number 7. So you could say then that AB is congruent to DC, because if a pair of sides is congruent and parallel, you have a parallelogram. Or you could say that AD is parallel to BC. So that's just kind of a warm-up section to get you thinking about all the different ways we can prove this. And it does get kind of confusing. There's a lot of ways to do this. All right, so next set of examples then. The question becomes, what value of x and y will make the polygon a parallelogram? The trick really to all three of these is that you're going to solve for x first, and that'll allow you to solve for y. So, for instance, number 12, if you tried to say, oh, well, if it's a parallelogram, opposite sides should be congruent, and you tried to jump ahead and say, yeah, x plus 2x equal y minus 1. The problem is I can't solve for x in that or y. The real thing is realize, oh, well, 3x had to be 6. Okay, x is 2. And then if x is 2, now I can plug 2 in for x. 2 plus 2 equals y minus 1. 4 equals y minus 1. Add 1. 5 is equal to y. So, I have to solve for x first there. All right, now number 13. Number 13. Find a value for x and y that would make this a parallelogram. Again, I have to use x in the equation first. And there are two ways I could go about this. The way they're kind of implying to make it easiest for you is that on a parallelogram, the opposite angles, if we go back to our theorems about them, both pairs of opposite angles are congruent. Okay, so we're going to show we have opposite angles are congruent. So I'm going to set 2x equal to 70, divide by 2, x is 35. Now once I know that x is 35, I can plug that back in for x here. So I can set 3x plus 5 equal to x plus 3y. And so 3 times 35 plus 5 equals 35 plus 3y. This is 105 plus 5 equals 35 plus 3y. 110 equals 35 plus 3y. Subtract 35. That gets us then 105, 80, no, 75 equals 3y. Divide by 3. 25 equals y. So x was 35, y was 25. Okay. And then on this last one, same exact idea, but this time we're talking about not side lengths, but diagonals. Okay. So, our property for diagonals is they bisect each other, meaning 3x would have to equal 12. So divide by 3, x is equal to 4. Now once I know x is equal to 4, plug in 4 for x, and I get 4 plus y equals 5y. Subtract a y. 4 equals 4y. Divide by 4. 1 is equal to y. All right. Now, the rest of this section, which I kind of sprinted to these examples, I know, but you can again pause me, rewind me to copy all this down. The last couple examples really are the kind of proof base for this section. So there's two different proofs we're going to do. And one we're going to do twice, and then one we're going to just talk about kind of the other things we could do with it. So let's see here. 15 says first, we'll do this one here, first A. By theorem 6.6, we're going to prove that if these two triangles are congruent, show that if both pairs of opposite sides of a parallelogram are congruent, the quadrilateral is a parallelogram. Okay. So, statements, reasons. One, given triangle MJK is congruent to triangle KLM. That's given. Now if you look at this here, what we're trying to prove is that both pairs of opposite sides are congruent. So I'm trying to show that JK and ML are congruent. Now the question is, why would I know that? Hopefully you'd say, oh, well, by the congruent statement, JK and LM correspond. Similarly, I'm trying to show that MJ and KL are congruent, and hey, they also correspond. Oh, so that's pretty easy. So too, we can say JK is congruent to LM, and JM, it's just KL is congruent to JM by, well, the two triangles are congruent, so their corresponding parts of congruent triangles are congruent. We haven't used CPCTC for a while, but that's where it comes into play. Now 3, MJKL is a, and this is my shorthand for it, parallelogram. I just say P-gram. How do I know that? Well, if both pairs of opposite sides are congruent, then parallelogram. I think I do that if I do that P-gram a lot. Now make that cleaner. It's both pairs of opposite sides are congruent. Then it's a parallelogram. Okay, the next theorem then, or the next one, I'm going to pause me if you need to or go backwards. The next one is given triangle MJK is congruent to triangle KLM. Okay, triangle MJK is congruent to triangle KLM. So given that, now we're going to prove this by theorem 610, which says if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. This one's going to be a little more work. Still the same exact idea. We have two triangles that are congruent. Given. Now, I just have to pick a side to prove that they're congruent and parallel. So I'm going to choose these two, JK and LM. And really that's the same thing as last one. I know JK is congruent to LM by CPCTC. The real trick is, how in the world would I prove that these two guys are parallel? And that's where it comes into play that, oh, wait a second. Angle KML corresponds to the angle JKM. And that as well. So angle KML is congruent to angle JKM, also by CPCTC. But the reason that's important is, hey, look at that. That's a pair of alternate interior angles. JK has to be parallel to LM, because if alternate interior angles are congruent, then parallel. Sorry, it's kind of sloppy, isn't it? That's good though, because now I'm ready to do this theorem 610. I know this is a parallelogram. MJKL is parallelogram 5, because if one pair of opposite sides is parallel and congruent, then it's a parallelogram. Okay, so again, if you don't have enough time, pause me, go back, listen through, answer the questions, and then, yeah. Now, the last example, I'm going to cheat a little bit. You've got graph paper, but I want to make mine look nice on the sheet here. So I'm going to pull up my graphing software, because it's on a computer. And if it opens up, there we go, GeoGebra. Nice little computer software. So I'm going to plot this out, plot these points out. A is at 2, -1. B is at 1/3. Whoops, not 1/3. I keep doing that. Not doing a comma. Mr. Moyer. C is at 6.5. D is at 7.1. Okay. Now, if you look at this, it does look like it's a parallelogram. But the reason I wanted to go through and graph this out instead of just taking an opinion for it is to note that I've got these sides here that I have that are opposite each other. Now, I didn't even think about this, but this does do one thing for me instantly to prove that these guys would be a parallelogram. If I show label, that's side A, that's side C, that's side D, and that's side B. And you can see here that A and C are both the same length, opposite sides. D and B are both the same lengths, opposite sides. So that's one way to prove that it's a parallelogram. Both pairs of opposite sides are congruent. Now, how we would do that besides just looking at it, that's where he comes into good old formulas like distance formula. Okay. We're also going to talk about slope. And we'll also use, actually, not to believe it or not, we use midpoint. I can't write. Which is x2 plus x1 over 2 and y2 plus y1 over 2. Now, if I go back to the drawing of this from the computer, whoops, wrong button. AB and CD are at opposite sides. So that's what we're going to do real quick. We'll just do distance formula. So x minus x, so AB, so 2 minus 1 squared plus negative 1 minus 3 squared. Take the square root of that. That'll be 1 squared plus negative 4 squared. And when I multiply that out, it's 1 plus 16, so it's root 17. So yeah, the opposite sides, so AB is root 17. Now CD is the other side, and it'll be 6 minus 7, 5 minus 1, which then will be negative 1 squared plus 4 squared. Well, negative 1 squared is 1, 4 squared is 16, 17. So we got an opposite pair of sides already congruent. Okay. Now the other pair of opposite sides. I'll do well, let's see here. What are the other pairs of opposite sides? I got to be careful with this, because if I don't do the right sides, I'll actually do the diagonals. So I had AB and CD. It's BC and AD. So 1 minus 6 plus 3 minus 5. That gives me negative 5 squared plus negative 2 squared. So 25 plus 4 is root 29. I'll do the same thing for AD now. 2 minus 7 plus negative 1 minus 1. Negative 5 squared, negative 2 squared. 25 plus 4 is root 29. Okay, opposite sides congruent as well. So that's one way to prove it, is I would prove that both pairs of opposite sides are congruent. The one thing I can't do is I can't prove angles are congruent. So that's one method there. The other method using slope is I could prove that both pairs of opposite sides are parallel, meaning they have the same slope. So I'll do that. So again, I'll do side AB, which slope will be y minus y, so 3 minus negative 1 over 1 minus 2. That gives me 4 over negative 1, negative 4. Excuse me, so AB has a slope of -4. Now I'll find the slope of CD. So 1 minus 5 on top over 7 minus 6. -4 over 1, -4. So same slope, parallel. And now do the same thing for BC and AD. BC will be 5 minus 3 over 6 minus 1, 2 over 5. And do the same thing for CD. No, sorry, AD. 1 minus -1 over 7 minus 2. Also gives me 2 over 5 for those, so same slope. Okay. Now the last way is this. Okay, so I've gotten 2 ways to prove it. Both pairs of opposite sides congruent, both pairs of opposite sides parallel. I've proven a parallelogram that way. I could also pick a single pair of sides. I could say, hey, look, let's show that AB and CD are both congruent and parallel. I could do that. Okay. The one thing I'm going to show last, though, is this one. I'm going to show that the diagonals bisect each other. And the way that's going to happen is, if they bisect each other, what that means is, where's it at here? That BE and DE are congruent and AE and CE are congruent, meaning that they both have the exact same midpoint. And that's the third thing I can do, is I can use the midpoint formula to do that. So same midpoint. So I want to find the midpoint of AC. Well, that'll be y plus y, x plus x over 2, so 2 plus 6 over 2. And then -1 plus 5 over 2. Which that gives us then 8 over 2, which is 4. 4 over 2, which is 2. So 4 comma 2. Now I'll do the same thing, but I'll do it for BD. I'll find its midpoint. So 1 plus 7 over 2. 3 plus 1 over 2. That gives us 8 over 2, which is 4. 4 over 2, which is 2. They have the same midpoint. That means they also must bisect each other. Now, this is definitely not the best way to go through this. It took a lot of time. It's a lot of material to go through a lot of problems. So you'll have homework tonight. You obviously have questions to answer as well. But you'll have homework tonight. Tomorrow we'll go over that. But we do have a quiz. So if you find yourself really confused with anything, you should be coming in after school on Tuesday. Or, sorry, today class, which is what? Yeah, Wednesday. I'm trying to think of the day this is going in. Coming after school either Wednesday today or come in school tomorrow before class. But you do have a quiz on Thursday over section 6.1 to 6.3. So, yeah, great. Thank you. That'll be it.